Yo, what's up? It's Nickel here, and I'm coming back with some information for your science notebook. This time, we're going to zoom on in and look at how that atomic structure that we talked about before can create these magnetic fields. So let's title this one Micromagnetics. And you can kind of see the structure here. We're going to look at an atom and see how the electrons flying around that atom creating a magnetic field. And then we're going to look at a water molecule and see what it means when we say that water is a polar molecule. Okay, let's jump in. So micromagnetics. Let's get a new color. Let's go with that yellow actually this time. Magnetic fields can occur when electrons are in motion. Now, what does that mean? Well, electrons are the things that are negatively charged, and these negative charges kind of fly around the central nucleus of an atom. So again, the negative charges are our electrons. The positive charges, the positive protons, are found in the nucleus. So if I draw a circle here around this, this is the nucleus, or this is what we would call the nucleus of the atom. You can see it's all positives, and then some of them don't have charges. Well, those are what we would call neutrons because they're not positive or negative. They have a neutral charge. Well, the electrons that fly around the outside of an atom, they actually want to pair up. They want to find another electron to pair with. And so what we find is around the atom, we find these areas that we find these pairs of electrons. So there's a pair in that top section. Here's a pair here in the bottom section. We call these electron orbitals because they're going to orbit this nucleus somewhere in this region. You're going to find them somewhere in there. But in this example of this specific atom, there's actually some random electrons that don't really know what to do. And they're flying around. They're flying around trying to find another partner. And they can't quite find anyone because they're just flying everywhere, going all over the place. And this is truly how electrons move. They're just everywhere. And they're flying around. So this one too, everywhere. Where's it going to go? And they're flying around. Well, if they are in motion, then they're going to end up making a magnetic field. Okay. Well, if we think about this, this actually relates back to our electromagnet. So that's our example. Is that when you put electricity through a wire, you're actually causing electrons to flow through the wire. And so when electrons are in motion through that wire, they create a magnetic field. They turn that piece of metal that would be a paramagnet, if you remember from your last pages, into a magnetic substance. And then that paramagnet, which is the metal core, becomes magnetic, and you can pick up those paper clips. Okay, well, let's summarize some of this. If an atom has unpaired electrons, they fly around and can generate a magnetic field. Or, if the electrons, those negatively charged things, remember those, are not evenly distributed in a molecule. Now, a molecule is when you have multiple atoms connected to each other. So the example we'll use here is water. So our molecule is water. There's 2 hydrogens and 1 oxygen in water. So there's multiple atoms. There's 3 atoms in 1 molecule of water. So if the electrons within all of those atoms in that molecule are not evenly distributed, either a positive or a negative pole can form, which is going to then create magnificent magnetism. And you all saw this in the green circle assignments. You got to witness one of the most wizardish things that is out there, and you actually caused water's path to be bent with the power of static electricity on the balloon. We'll get into static electricity later on in the next science notebook pages on the electrical properties. But anyway, for now, water, like we said, we all know this, it's H2O. It's common vernacular in our dialogue. So we have 2 hydrogen atoms. So that means that these little blue things here are our hydrogen atoms, and they're really, really small. purple one below is our oxygen atom. And oxygen, you can see, is a big ol' atom. And it actually is going to try to steal the electrons away from hydrogen. So the electrons live kind of out here in this area. So the electrons are kind of out here in this area. That's what the gray lines are showing. The gray lines are showing that they actually share some electrons. So some of oxygen's electrons also kind of jump up in there. And what we find, though, is that since oxygen actually has some other electrons kind of floating around it, it's going to share some electrons up here. But basically, the pole of electrons ends up being mostly on this side of the molecule, which leaves this other side of the molecule as being positive. Protons are positive. This ends up being a positive pole, not a proton, but just a positive pole. We have a negative pole. And if you can think about this, like we looked at magnets, it ends up being something just like a magnet. Well, what that means then is that we have that type of positive charge in the top and the negative charge in the bottom. And so water molecules actually are going to build in a way that a magnet builds, and they're always going to have the positive be attracted to the negative part of the molecule, and that means that it leaves, which I messed up there, the negative part of the molecule. No, I did. The positive part of the molecule here at the top, the negative at the bottom. So we end up having this type of relationship start to build when you have water molecules around each other. And so since it has a positive and a negative pole, we call this a polar molecule. And that's why water is going to behave differently when it's around the presence of a magnet. But the thing that's so crazy is you can't just take a magnet and put it by water and just expect it to be moving all over the place all the time, because this magnetic attraction right here between these molecules is so strong. There's some lousy little north-south bar magnet. When it comes into contact and comes close to these, a lot of times these water molecules just don't even care. They're like, whatever, bar magnet, you're not going to affect us. We're stronger than you. But in some cases, if your magnet's strong enough, or if you have the right type of environment, you can end up causing the water molecules to behave differently. Because it's a polar molecule, it ends up behaving differently in the presence of a magnet. So that's a zoomed in view of magnetism. And this hopefully will help you also make the bridge between magnetism and electricity, which we'll talk about next time. All right, I'm out. See ya.